Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
Okay, thank you. You may sit down. Okay. Now, in our last lesson, we studied a topic which is on pressure, and we basically looked at pressure in solids. So pressure, as we have seen, is simply the force per unit area, force that is applied on, let's say, an area. So pressure can be determined by the area. Okay, whether the area is large or small, okay, it depends on that. If the area is quite large, the pressure will be small. If the area is quite small, the pressure will be quite high. Now, in this lesson, we're basically looking at pressure, and this time the subtopic, the topic of discussion will be on stress. Now, can somebody tell me what is stress? Okay, Mary, you give us an explanation of stress. All right, let's see. Is it also a pressure? Okay, good. It is also part of pressure, but where is it applied? All right, looking at this stress is simply another form of pressure which is applied on structures and materials. For example, if an engineer has to design a bridge or something like a building, he has to know the amount of pressure that will be exerted by that beam or any object that is placed in the building or the bridge. So in this lesson, we'll be basically going through and then have a look at the stress. All right, what I will be asking you to do now is for those pilot teachers, you can ask the students. I will give you notes at only the notes, and then after that I will ask you to do some activity questions on the topic. Okay, quickly go through and then copy these notes. All right, from the question, what is stress? All right, this is the definition of stress. It is also one part of the pressure, or another form of pressure which is always found on materials and structures. All right, now on to that second piece of information. It is also given by that formula, the stretching force over the area, and stress is normally in newtons per meter square. Okay, as you can see, it is having the unit for pressure. So we can simply say stress is also a pressure, but this time it is found on materials and structures. Okay, that m square is simply meganewton per meter square. Okay, it is meganewton per meter square. And the symbol for that stress would be a Greek letter, which is a sigma. All right, this is just an example. You don't need to have this information. I'll go through my explanation and then I will tell you which notes to copy. All right, for example, if foundations of this are being designed, or if engineers are trying to design one of these, what they must do is to consider if this bridge will sink. Okay, if the pressure is quite high. Okay, what area must be, or must the foundation stop this from happening? So when these are being considered, they must always consider the foundation, because you know that area determines the pressure which is to be applied. So larger the area of the foundation, then the pressure will be quite small. Okay, so in this case, given an example, right? This bridge, for example, if this one can be 1.2 meganewtons, then you may have about 0.6 meganewtons which will support the structures. And given from that formula, and we placing that, we can always find the area which can support that amount of force, okay, which is about 1.2 meganewtons. So in this case, if you want to find the stress equals to force over area. But this time it is given, or it is asking you to find the area which is equals to force over the stress. And then we have seen that almost about 0.6 meganewtons can support that 1.2 meganewtons. So it is giving us an area of 7.5 meters square. All right, you can go through, just take this formula down. when do you stop at this point in time? At this time? Period 8 from? Let me see. Okay. We may run late into the next period. What do you have next? All right. Quickly have this. Okay, the first one is transverse stress, and it happens when the force acts across the object or at right angles. Right, here is an example of transverse stress. Right, looking at this, you will find that the force will be either at right angles, meaning that it may be downwards this way, or it can be this way across. Okay, so the forces are either across or at right angles. Okay, these are the example. If you want to quickly just get the diagram, then I'll give you an example of the next stress. All right, here is another example. Okay, the torsional stress, all right, occurs when the structure is rotated or twisted, and usually along the length of the structure. That is torsional stress. You have seen torsional forces of force torsion, but this time we are looking at stress or torsional pressure. Okay, here is an example of this type of stress. Okay, looking at the first one and how, okay, so it is twisted along the length. Okay, you see the point where the twisting has to take place, and that is where the pressure will be, or the stress will be applied. Okay. Okay. This is the third one. There are four of them. Shear stress is occurs when the sideways force causes two surfaces to slide past each other. Okay, here is an example of that. Right, you will find that this first slides over the other. So that means the area over here, which was supposed to join this area, has slide below that level. So, in other words, shearing has taken place. And finally, to our final one that is variable stress. All right, quickly go through. All right, this stress can be caused by the combination of those stress which are being expressed earlier. All right, you can have torsional stress, or it can be shear stress, or even transverse stress. Okay, they can occur simultaneously. It can be randomly or regularly. Okay, this one should be simultaneously. Okay, this S for this word is up here. Okay, pilot students and teachers, I am now giving you the activity questions. This is the first question which needs calculation. Right, the second two questions will be just explanation. So just have these questions down quickly. And that is question A. Okay. Who's finished with that question? You copy that question, do it. Okay, and answer it. This one. Finish. I am going to give you the next two questions shortly. Right. Here comes the questions. Can we have somebody who should answer? Were you here yesterday? You were not here. Okay. You do this question. D with yours, and you go for the last one. Okay, the last C, question C. asking you to calculate the stress. Okay, tensile strength, tension, stress.
For the newtons, do we have to convert it?
What is that question?
Question A.
Question A.
We just divide 5 into 500, or we have to convert the newtons?
No, newtons is okay. Only converting this
Yeah.
centimeters. How do you calculate the area? Force over the area. Stress. Given from that equation. Force is there already. You just calculate the area. The diameter is 5. So how do you calculate the area? Okay. Area equals to 3.14 times half of 5 is 2.5. 3.14 times 2.5. 19.25 centimeters. That is the area. Okay, 400 divided by 19.26. Okay. How did you arrive with the answer? Okay. If we do it that way, 400 over 19.26. Okay, since this one is a centimeter cube, you are trying to change this one. So this one will be 400 because you are trying to convert to a larger unit. So you will have to divide 400 over 1 times 19.26 over divide by 100 by 100. And when you do the conversion, it will be, sorry that okay, 400 times 10,000 over 19.26. What is the answer? Okay, it's 2.07 times 10 to the 1, 2, 2, 3, 4, 5. Okay, 5 pascals. Okay, yeah. All right, we will now go on to the correction of those exercises. We'll ask the first person to come up and then show your working out on the board. The other two will be just explanation of your, okay? Where is it? Okay. After you finish, you give it to. For question A will be you will do question C. Yeah, question C. And B, you'll be question B and then B C. Not yet. Okay, the first person. Okay, you finish. Okay. Who's this? Ume, you go for question number 1. All right, just go do your working out on the board and then. Okay, you get ready. She's going to do B and then you C. Okay, here. Start from this. Just do it there. Okay, you face the camera.
How do we work out the area for the room?
Area, you were given the diameter, so that is pi r squared. Okay, you cannot. That's right. You from that given sigma or the pressure equals to force over the area. You were given the diameter of the row, and you have to calculate the area of that diameter of the row. Yeah, that's right. And then you will find the tensile stress. Okay, there's a tension stress that is going through that row. Okay, you get ready.
Firstly, I worked out the area for the rope, which is 19.26. Because it is in centimeters, I converted that to meters by divided by 100 times 100. Then I came up with 400 times 10,000 on 19.26, and the answer is 2.07 times 10 to the power of 5 pascals.
Okay, very good. So the answer is 2.07 times 10 to the 5 pascals. Now, how did he get this 19.26? That is area, which is pi r square. So that is 3.14 times. How of that 5 will be? 2.5 times 2.5. So that gives you 19.26 centimeters square. But how do you convert that to meters? Right, simply that's 400 over 1 divided by 19.26 over 100 times 100. So you get this answer as 400 over 1 times 10,000 over 19.26, and that gives you this answer over here. Okay. All right, we'll go to the last question. Jolly. That is question B.
Torsional stress occurs when the structure is rotated or twisted, usually along the length of a structure, whereas shear stress occurs when a sideways force causes two surfaces to slide past each other.
All right, she has just to distinguish between the stress. Torsional is bending or twisting a material, and then shear will be when this object or material are sliding against each other. All right, finally to question C, Rachel.
To distinguish between force applied to a material and the stress it experiences, says the force applied to a material is the push or pull that deforms the shape of the object, and the stress of the material depends on the amount of force applied on an area of 1 square meter of the object.
All right, basically for question C, it depends on the area. Okay, the stress will be quite large if the area is small or less. If the area is quite large, then the stress will be quite low. All right, now quickly to summarize what we gone through, stress is also another part of pressure. Okay, we can call it as, it has the same unit, pressure, but this time you find that it is a pressure that is acting especially on materials and structures. All right, you have seen the 4 types of stress. Right, the first one is transverse stress, and then you have the torsional stress, shear stress, and variable stress. Now each one of these have their own significance and where they have to be applied or how they are applied. And you have just seen how you can calculate especially the pressure or the stress on these materials. All right, so that brings us to the end of the lesson. All right, our keyword for today would be stress. Okay, you can all stand up now. Okay, once again, good afternoon, pilot teachers and students, and good afternoon, class. Okay, thank you.